Welcome to Chapter 5, Multiple Linear Regression. In this chapter, students will be able to 1. Incorporate multiple quantitative predictors into a multiple linear regression model after performing model adequacy checking. 2. Evaluate and validate a multiple linear regression model. 3. Use statistical software, namely SPSS, to run the multiple linear regression analysis. A multiple regression model, MLR, is a regression model with a single dependent variable and more than one independent variable. It is the most widely used of all statistical methods. Besides, the general model first order with K predictors can be seen as follows. Continuously, the MLR will have to use the assumptions that have been explained in Chapter 4. The assumptions are linearity, independency I, normality N, error variance constant constancy E, and zero error term Z. Students will be able to check for the assumptions using SPSS software. Example of MLR can be seen from a study about the soft drink manufacturing. The example have one dependent variable that is the delivery time Y, and two independent variables that are the number of cases of product stocked X1 and the distance, in feet, walked by the route driver, X2. As the data was keyed and run using the SPSS software, the following output can be used to interpret the descriptives of the three variables. Besides, the scatterplot matrix can be used to examine the linearity of relationships between dependent and independent variables. Other than the graphical methods, the numerical methods can be applied by examining the correlation matrix. The value of coefficient of correlation, R, can be used to identify the strength, strong, weak, moderate, and significant variables between Y and X. This also has been explained clearly in Chapter 2. Additionally, the interpretation of the coefficients are based on the beta 1 and beta 2. To evaluate the multiple linear regression model, several important statistic values can be applied, such as 1. The standard error of the estimate. 2. Hypothesis testing, for testing the validity. 3. Hypothesis testing for each independent variable. The coefficient of multiple determination R² and the adjusted coefficient of multiple determination, adjusted R², need to be examined in MLR. The formulas are as follows. The differences between R² and adjusted R² are the value of R² generally increases as more explanatory variables are added to the regression model, while the value of adjusted R² may increase, decrease, or stay the same as more explanatory variables are added to the regression model. Continuously, students can see the assumptions based on LINZ as follows. Thus, only if the model is reasonably good and all the assumptions of regression model building are fulfilled, we can use the model for forecasting or making inferences. In MLR, the final model can be developed by identifying the insignificant independent variables manually and remove the variable using the independent test as shown previously. However, students can also perform variable selection methods to get the final model without manual procedure. There are many regression techniques that can be used to determine which set of independent variables are the most important predictors of the dependent variable, y. The first one is stepwise regression. This is the most widely used variable selection method in MLR. The steps involve forward and backward methods in the same procedure. For step 1, students have to consider the f-value test statistic based on different model of x and the critical value. Comparing the test statistic and critical value will identify the variables that can be selected. The procedure continued with step 2, step 3, and step 4. From the 4 steps, step 1 and step 2 represent the forward method, which identifying variables that will be selected, while step 3 represents the backward elimination, where this step will either drop or not drop the previous variable that has been selected. Step 4 will back with the forward selection again. The combination of these two methods in stepwise made it the most widely used variable selection method in MLR. Next, the second method of variable selection is the forward selection method. The forward selection method is similar to the stepwise method. Variables are selected one at a time based on their importance in explaining the dependent variable. The only difference is that the forward selection technique does not check the partial f values corresponding to the predictor variables that have been entered into the model in an earlier step. These are the two steps using the forward method. Lastly, the backward elimination method can also be used. Unlike the first two methods, the backward elimination method begins with the full model and then drops variables that are least significant one at a time at each step based on their partial f values. And these are the steps in backward elimination.